Friends, today we will discuss problem on Green's theorem. So coming to the problem, so verify Green's theorem for the line integral along the curve C. So f bar dot d bar where f bar equal to x square plus y square into I minus 2x by j. The curve C is the rectangle bounded by, so clearly it is a rectangle, curve is a rectangle, so bounded by y equal to 0, y equal to b, x equal to a and x equal to 0. Now coming to the graph, since so clearly, so x axis and y axis, it represents y equal to 0 and x equal to a, which is x equal to a and y equal to b. So clearly it is y equal to b. Then the point here is a comma b. So here the point is a comma 0. So here the point is 0 comma b, and finally this one is 0 comma 0. So we have 4 points. So O, A, so B and C. So here we have 4 curves. It is a closed curve since it is a rectangle and it is a closed curve. So the direction of the curves is anti-clockwise, so that from O to A, so the curve is C1, A to B, it is C2, B to C, it is C3, and C to O, it is C4. So that we have 4 curves to be integrated. So that C1 along OA, C2 along C2, which is nothing but AB, C3 BC, C4 it is CO. So that coming to the problem, so from Green's theorem, so by Green's theorem, so what is our formula? The line integral along the curve C, so p dx plus q dy equal to the double integrand over the region R dou q by dou x minus dou p by dou y into dA. So clearly we have 4 curves to be integrated. The first curve is along C1, along C2, along C3, along C4. So that the first one is along C1. So that if it is along C1, clearly from O to A, which means 0 comma 0 to A comma 0. Clearly if you observe this, so x value ranges from 0 to A, but coming to y, it is 0 to 0, no change in y. Since x is ranges from 0 to A, but clearly y is a constant, no change, which means the constant. Since if y equal to 0, a constant, no change, which means the derivative of y also is equal to 0. Now, so from the given problem, so we have f bar is what? X square plus y square into I minus 2xy into j. So we need to evaluate a line integral over along the curve f bar dot dr. So we already know that what is r bar? Xi plus yj. Then what about dr bar? So dxi plus dyj. Then what about f bar dot dr? So f bar dot dr bar equal to, so clearly f bar is what? X square plus y square into I minus 2xy into j dot, so it is not a multiplication, it is a dot product, so dot dxi plus dyj. Now coming to the vector dot product, so if we have same direction I, then the unit vectors of same direction is 1, then it is x square plus y square into dx. So I bar dot I bar is nothing but 1, so that x square plus y square into dx. Now coming to the second one, I bar dot j bar equal to 0, so I need to take this, then minus 2xyj dot dxi. So j bar dot I bar is also 0, then on the last one minus 2xy, j bar dot j bar is what, 1, so that minus 2xy into dy. So that is f bar dot dr bar. Then what we need to evaluate? Integral of line integral along the curve f bar dot dr bar equal to, so line integral along the curve x square plus y square dx minus 2xy dy. So this is the problem we need to integrate. Now along the curve C1, x is ranges from 0 to 1 and y is what, 0, which is nothing but dy also equals to 0, so that, so integration of along the curve, so which is 0 to a, the bounds are 0 to a, y is what, 0, so that wherever we have y, so replace with 0, so that x square plus 0, so no need to take this, into dx minus 2x into y is 0, dy is 0, since these two values are 0, so no need to take this. Clearly we have what, we have x square dx, since y equal to 0 and dy also equal to 0, so that this value completely eliminated. Then what about the integration of x square? It is x cube by 3 and the boundaries are from 0 to a. So then what is the final answer? Substitute the upper boundary, which is a cube by 3. So this is the first one. Now so this is the main problem. Now along C1 is completed, then coming to the along C2, so which is nothing but the direction from A to B, so the bounds are from A0 to AB. So along C2, what we have, so clearly bounds are from A0 to AB, so which means from A to B, so which means A0 to AB. So clearly, so what we observe from this, x, no change in x, but the change in y coordinates from 0 to b. So clearly x is from a to a, so that no change. Clearly x equal to a, so which means dx equal to 0. If it is no change, the derivative should be 0. So no problem with this. So clearly x equal to a constant, so the derivative of x is dx, and for y, so clearly for a is a constant, so derivative of a is 0, and y is ranges from 0 to b, so that clearly coming to the line integral, boundaries are 0 to b, and coming to our problem, so it is x square plus y square into dx. So here what is x, a, so that now substitute in place of x we have a, since it is a square plus y square into dx is what, 0, minus next x is what, a, so that coming to the next one, 2ay dy. Finally what we have, 2ay dy. Now it is 0, so minus 2a is constant, y square by 2, the boundaries are 0 to b, 2 gets cancelled, so it is minus ab square. It is the final answer. So clearly dx is 0, so this term is eliminated. Minus 2a is a constant, so for integration of y, it is y square by 2, 2 gets cancelled, since it is ab square. Now the third one is along C3. So along C3 what we have, the boundaries, so AB to 0 to B, so it is BC, which means B to C. Clearly it is AB to 0 d. So clearly x is ranges from a to 0 and y is ranges from b to b, so that no change in y, which means y equal to b, no change in y, so which means y equal to b. Clearly dy is equal to 0, the derivative of constant is equal to 0. Clearly coming to the line integral, we have to take, so from x is from a to 0, so that a to 0 and y is what, b. Now substitute in place of y what we have, b, and dy is 0, so that here we have y, so that it is x square plus b square into dx minus, so clearly we have dy, so dy is what here, 0, so that since it is 0. Now what we have the boundaries from a to 0, so they clearly, so it is a wrong order, so that we need to change the order, so that we need to take minus. Why? Because clearly lower boundary consists of the least value, upper boundary consists of the highest value, but here these two are different. So lower boundary is maximum, upper boundary is least, so that we need to transform these boundaries from 0 to a, so that if you want to convert these boundaries, you need to take minus x square plus b square into dx, so that coming to the integration, for x square it is x cube by 3 and b square is a constant, the integration is x, 0 to a. So why? Because so b square is a constant, for integration of 1 is here x. Now substitute the upper boundary, it is a cube by 3 plus ab square, since it is minus a cube by 3 minus ab square. This is along C3. Now after along C3, finally we have along C4. So coming to the graph, along C4 it is 0 to b, 0b to 0 0. So 0b to 0 0. So clearly no, sorry, 0b to 0 0. Clearly x ranges from 0 to 0, no change, but y ranges from b to 0. Since x is ranges from 0 to 0, no change, what about this x equal to 0, and y is ranges from b to 0, so no problem. So clearly if x is 0, what is the derivative? Clearly is equal to 0. Now coming to the line integral, so y ranges from b to 0, and then dx is 0, the first one is 0, minus, coming to the second one, here the first one we have dx, so that here we have dx is 0, so that this complete value is equal to 0, and then minus 2xy dy, we need to integrate. Now coming to the integration, and one more thing here is x equal to 0, so that we replace x with 0 into y, so the complete value is equal to 0. So along C4, so what is our value? That equal to 0, so that along C4 it is 0, at about C3, at about C2, and it is about C1, so that adding all these, what we get, finally the line integral along the curve C, so f bar dot dr bar equal to, along the curve C1, which we have a cube by 3, and along C2 we have minus ab square. Next along C3 we have minus a cube by 3 minus ab square, minus a cube by 3 minus ab square, and along C4 it is 0. So along C1, along C2, along C3, and along C4. So a cube by 3 gets cancelled, so minus ab square, clearly it is minus 2ab square. Now the line integral along the curve C is completed. Coming to the Green's theorem, so from this one, what is P? clearly what is P? X square plus y square. So clearly P equal to x square plus y square. What is Q? Minus 2x. Coming to the Green's theorem, what we need to find? Dou Q by dou x and dou P by dou y. So here dou Q by dou x is what? So if you want to integrate with respect to x, treat y as a constant, so that minus 2y into, for x it is 1, so that minus 2y, and then dou P by dou y. So if you want to integrate with respect to y, treat x as a constant, so that derivative of x is 0, plus for y square it is 2y, so that it is 2y. It is a partial derivative, so that if you want to differentiate with respect to x, treat y as constant, so that minus 2y is constant here, and differentiation of x is what? 1, so that minus 2y. Then coming to the first one, x square plus y square, we need to differentiate with respect to y. So if you want to differentiate with respect to y, treat x as a constant, so that the differentiation of x square is what? 0, plus y square is what? 2y, since it is 2y. Then coming to the Green's theorem, that is in R, dou Q by dou x minus dou P by dou y into dA. Now coming to the two integrals, and the boundaries are here. X boundary is from 0 to A, and the boundary of y is from 0 to B. So 0 to A, 0 to B. So these are the y boundaries and these are the x boundaries. Now dou Q by dou x, so it is minus 2y minus dou P by dou y, it is minus 2y. So if you want to integrate with respect to y first, so that is dy into dx. Then so minus 2y minus 4y, take minus 4 constant outside, 0 to A and 0 to B. So here we have y dy to dx. So clearly here we have minus 4y, so minus 4 is a constant, put it outside. What is left alone? So y. So minus 4 integration of 0 to A. So integration of y is what? Y square by 2, and the boundaries are 0 to B. Now substitute the boundaries. So minus 4 b square by 2, integration of 0 to A dx. 2 ones are 2, so 2 2 gets cancelled. So minus 2 b square also is a constant, integration of 0 to A 1 dx. So clearly integration of 1 is what? X, so that minus 2b square x, and the boundaries are 0 to A. Now substitute the boundaries. Minus 2b square, for x it is A, so that minus 2ab square. Now from the line integral, so what we get? Minus 2ab square, and from this what we get? Minus 2ab square. So LHS is equal to RHS. So line integral equal to Green's theorem. So that clearly if LHS equal to RHS, Green's theorem is verified. Okay students, thank you.